Hi, my name is Jonathan Marinovic, and this is my capstone project, the barcode sorter. The main goal of this project was to get a single ABB robot to pick up and sort Jenga blocks on a conveyor by the barcode scanned that was printed on them. While it seems simple, there are numerous subsystems that must work in lockstep to actually achieve this, and without a guide on how to build the system. I also had to create training and documentation so that this system could be rebuilt by someone else. The first subsystem was the barcode scanner to the Wonderware software. The major issue with this was that the scanner was not configured to talk to the computer. Researching documentation and software from the manufacturer uncovered a way to copy a configuration from a working barcode scanner into mine, allowing it to talk. Getting the light trip sensor on the conveyor required some calibration to set when the sensor would go off when blocked, and studying the wiring diagram to properly connect the system to the Siemens PLC. Now, connecting Wonderware to the PLC required some knowing on how to properly configure these. Numerous false starts before these two separate systems were able to start talking to each other reliably. Wonderware then had to be programmed to make decisions based on the barcode scanned. The language was in VB script and is very similar to the Arduino C code used in our sensor and robot projects. With basic if-else statements, I could send separate commands over to the PLC via Ethernet based on the barcode. I created a simple interface on the second computer to give which barcode was last scanned, if the trip laser was activated, and a counter of the number of blocks that had been sorted. We now had to connect this to our ABB robot, which became the most difficult part. The breakout board used was custom made years ago and no documentation existed. After days of trial and error trying to use the software, we found the old connector that was used a few years ago in a similar build and copied the pin combination used to allow the PLC to communicate with the ABB robot. With communication set up between the robot to the barcode scanner, we had to devise a way to put the Jenga blocks on the conveyor and how to scan them. By putting Jenga blocks on their side, it was easier both to scan the block and high enough to trip the laser without modification. This, however, required precise placement of each block. The ABB robot arm became the method of actually putting the block on the conveyor as well as taking them off to be sorted. Now required the building of the dispenser. I used a plate of 1/2-inch acrylic to be laser cut into the various parts, designing the parts in SolidWorks. I then exported them as drawing files that were compatible with the laser cutter itself. With various parts cut, I first tried to drill and tap the holes to fasten them together with bolts. However, this required drilling multiple holes with a high degree of precision, which took too much time and could ruin the parts if incorrect. Epoxy was used, which was much faster and could create precise fits by squaring off each part from the last. Finally, I created the pneumatic system to run the vacuum on the robot and the dispenser actuator. I used 2 supply-side regulators for the actuator. While 2 exhaust regulators would give a smoother control, I decided this added complexity that would tax the small work area I had. The Festa parts then had to be interfaced with the PLC. I used alligator clips to provide the temporary connection required, since adapting the cables with terminal ends would ruin them and the project had to be broken down afterwards. Now I had to program the robot using the teach pendant, programming it in rapid code. It was simpler than both C and VB script, and by far the easiest part of the development of the system. And then, once all of it was put together, I could demonstrate the sorter. This, of course, was not the end of the finished product. I created a training manual with step-by-step instructions on how to rebuild the sorting system, and created a teach pendant training video for anyone else who would work with these robots. In conclusion, this final project wasn't just the culmination of every other mechatronics class. The project had problems that required learning new technical skill sets before they could be solved, and getting different systems to communicate over a variety of protocols. In all, the project became a lesson in learning how to solve these problems rather than learning what specifically to do. I thank you all for watching this video, and I hope you enjoyed the show.